Hey guys, I'm going to just go over a little bit of the 2.2 assignment stuff and the 2.3a stuff, so the graphing parabola stuff. So on 2.2, I'm going to go over number 3 and then one of the problems on the back. So this is our equation. And remember, this 2.2 assignment, you can use graphing calculator. So I'm going to take my app here and clear that out. I'm going to type in this equation in here. We'll put -3 parentheses x plus 1 squared minus 1, and press save, press graph, and that's what it looks like. Okay, so what I'm going to do with that is I'm going to put that right next to here. I'm going to say, where's the vertex, that little top point? It's at -1, -1. So I'll go over here, and I go to -1, -1, plot that point. I'll come back here and say, oh, where's that crossing the y-axis? It's right there at 0, -4. 0, -4. So mark that on here. You can also see there's a point at -2, -4. And if I go over to +1, it looks like it's -13. So +1, -13. And there's also on the other side -3, -13. So then I'll fill in on my paper. The rest of that shape. And there it is. So you might notice that some of the other parabolas are this shape, like number 1 and number 4 are both going up parabolas, but since this one's got a negative in the equation in front of it, that flips it upside down, makes it a down parabola. It's negative, so it's like a frowny face. Okay, let's do one problem on the back. Which one was? Let's do number 7 here. Number 7. Okay, so same thing. I'm going to go in my app. I'm going to go to the equations part. I'm going to put in that equation. So x, we'll just start from scratch here. X minus 4 squared minus 2. Save that, graph that, and that's what it looks like. So I'll first find the vertex. That's at 4, -2. So I come over here to my paper, and go to 4, -2, plot that point. I'm going to go back here. Okay. And where's it crossing? It's crossing between 5 and 6, like about 5.5. So the x-intercept about 5.5 and about 2.5 on this side. So I'll plot both of those. And I'll find a couple more points. There's one about 2, 2. And then over here at 6, 2. And at 1 and about 7, 1, 7. That's up above where it would show on this graph. So I'm gonna draw the shape in, connecting those points, and there you go. So just find the vertex point, find a few more points, and draw the rest of the shape in. Okay, now let's look at that other worksheet, 2.3a. Okay, so this front side, you can do what we were doing on that last one and graph it with your graphing calculator app, or you can do it by hand and make a table and plug in x numbers into this equation and see what it gives you for y. So if x is 0, then I'd have 0 plus 4, which would be 4, squared is 16. Negative 16 plus 3 is negative 13. If x is 1, this will be 5. 1 plus 4 is 5. 5 squared is 25. Negative 25 plus 3 would be negative 22. Oh, that's getting on the positive side, but I need these negative numbers. So let's try negative 1, because this is getting too high, too low. We want to be where it'll show up on the graph. So negative 1 plus 4 would be 3. 3 squared is 9. So negative 9 plus 3 would be negative 6. That's still too low to show up on the graph. Negative 2. Negative 2 plus 4 would be positive 2. 2 squared would be 4. Negative 4 plus 3 is negative 1. So negative 2, negative 1. And remember, at negative 1 it was down at negative 6, so it must be going down. We get the next one, negative 3. Negative 3 plus 4 is 1. 1 squared is 1. Negative 1 plus 3 would be 2. So that's going to be negative 3, 2. And we'll do a few more. Negative 4. Negative 4 plus 4 is 0. 0 squared is 0. Negative 0 is just 0. 0 plus 3 is 3. Negative 5 will be, make this negative 1. Negative 1 squared is 1. Negative 1 plus 3 is 2. And if you keep going, you'll find that it looks like that. Okay, so as you can see, it might be easier just to type it in here and graph it, see what it looks like. But if you would rather do it by plugging in it, finding the individual points, that works too. You just have to plug in the number for x, all these different numbers, and see where y goes for each of the x's, and plot all the points and connect it. So that's for these first four problems. Now number 5. Okay, number 5 through 8. So looking at this equation right here, it should look kind of familiar. Negative x plus 4 squared plus 3 equals 0. What did we have up here? Negative x plus 4 squared plus 3. So what you're going to do is say this is the same as this. That's what you got to notice. You say, oh, that is just this. So when does this equal 0, huh? It equals 0 when y is 0. And where is y 0? Y is positive up here. It's negative down here. Remember, this is the y-axis right here. Y equals 0 when you're along this x-axis. So right there and right there is where this equation where y equals 0. So the solution is x equals negative 2.3, you can estimate, and negative 5.7. And if you round it a little different or whatever, that's okay. So you got to find the x-intercepts. The x-intercepts are what make that equal 0. And this one right here, x plus 4 squared plus 4 equals 0. That goes with this one, y equals x plus 4 squared plus 4. So these 4 correlate to these graphs, and the equation equals 0 when y is 0 on the graphs up here. Okay. This second page, or the back of the first page, same exact thing. F of x is just like y equals. Don't let it throw you off, okay? It's just an equation, a function called f instead of y. And x, that's just saying what the variable is. All right. Look back at problems 1 through 4 and 9 through 12. How can you tell from the equation whether it is going to be an up parabola or a down parabola? Well, I kind of pointed out part of that, I think, earlier. This negative right here, if there's a negative sign in front, it's going to be going down. This one right here is going to be an up parabola because there's no negative coefficient in front of this part. So this one and this one will both be going down because of that negative there. Okay, so that's the A value. So if A is positive, it will be an up parabola like this. If A is negative, it's going to be a down parabola, going down on the sides. Okay, so that number right there, if it's negative, so like this one right here, -2. Number 10, A is -2. Since A is negative, that's going to be a down parabola. On this one, A is +2. It's going to be going up. This one, A is +1. So that's going to be going up on the sides. Okay. That's for number 17. On the graph, please plot those three equations. That is just something that you can type in your calculator, all three of those, and the only difference basically is going to be how steep it is. It's going to be going like this, then the next one's going to look more like that, and the next one's going to look even a little more steep. So it's going to stretch it up, make it steeper. That's what A does, because 2, so these three equations, they're all the same except A is 1 on this one, A is 2 on that one, A is 3 on that one. That's the only difference between these three equations. So 2 is going to double all the points, and they're going to be twice as high up as they would have been. 3 is going to triple it. It's going to stretch it vertically by a factor of 3. So that's what you can kind of explain for number 19. This one, all the equations are the same except for those, and you can graph those, and this one will be pretty easy to tell what the difference is. How does the K number affect the graph? So this one, K is -3. This one, K is -4. This one, K is -5. Sorry. So this equation has K of -3, that one it's -4, that one it's -5, and you'll be able to tell there's a certain part of this equation that is moving when you graph it, and K is telling you where that is going to be. Okay. Number 22. What in the equation tells you where the vertex, top or bottom point of the parabola will be? What tells you? So what you're going to look at is look at the equation and look at the vertex. See, how does the vertex relate to these numbers in the equation? Like on this one, the vertex is -4, 3. Right there. -4, 3. How does -4 and 3 relate to the numbers in this equation? That's what you're going to look at and see if the pattern keeps going in all these parabolas. So that's what you're going to answer for that one. And then how does graphing quadratic equations relate to solving them? That's just saying in a sentence or two, how did we use this graph to find these points? Because this and this were related, and we used this graph of this equation to help us find these 2 points, the solutions to that equation. So just explain how that worked. Okay. Hopefully that helped some of you that were stuck and still confused on some of this stuff. See you in class next week.